Welcome students. Now we are going to see the various types of arc welding technique. In that, let us see first arc welding technique, that is the TIG. The TIG, that is tungsten inert gas welding, or this is also known as GTAW, that is gas tungsten arc welding. Gas tungsten arc weld. Okay. So I will draw the diagram of setup. So dear students, let us see, this is the setup for the tungsten arc welding. So in tungsten arc welding, the electrode which is going to use is made up of the tungsten, and very importantly, which is non-consumable electrode, that it is not going to melt. Okay, but the arc is going to produce at the tip of this tungsten electrode, and it is used for melting or joining of the material. Okay, so this is the speciality, that is, please remember, in TIG welding the electrode is non-consumable and it is made up of tungsten. Please remember. Now in this electrode, if you talk about this tungsten electrode, in that we are adding the thoria or thorium oxide around 1 to 2%. So in this electrode we are adding 1 to 2% of thoria, which is nothing but the thorium oxide. Also we are adding 0.15 to 0.4% of zirconia, which is zirconium oxide. Okay, into this tungsten electrode. Now see, this tungsten electrode is less expensive, but the current carrying capacity is also minimum. So when we add the zirconia around 1 to 2% into this tungsten electrode, the current carrying capacity of the tungsten electrode goes on increasing. At the same time, we are getting the stable arc. Whereas the zirconia, if you add it, some melting point of the electrode is going up. So this is the reason why we are adding the zirconia or thoria. So that's why the name of the electrode is also known as the thoriated electrode or zirconiated electrode. Okay, now basically see, this TIG welding process is made for the joining of many materials, but amongst these all, the common materials that are specially welded by this TIG welding process is aluminum, magnesium, very highly reactive materials, and the stainless steel. These are the most widely welded materials from the TIG welding. So कौन से material है basically? Aluminum, magnesium and stainless steels, most commonly welded by this TIG weld. Okay, now if you look at the setup, here we are providing the inert gas into this welding. So that's why the name is, see, tungsten inert gas. So why? So this inert gas, basically there are argon, helium, carbon dioxide. These are the inert gases are there which can be used. But in TIG welding, generally argon gas is used for the shielding of this weld pool or weld zone, so that definitely there will be no any atmospheric contamination from the oxygen or the nitrogen, so that your weld is safeguarded here. No any contamination can enter into this weld because of the inert gas. Okay, now as the arc is going to generate at the tip of the electrode, so what we are doing, we are keeping the electrode at minimum temperature, or we are cooling down the electrode by supplying the coolants through these pipes which are wrapped around the tungsten electrode. See, these are the pipes which are wrapped around, from which the coolant is flowing. So the coolant tank, the coolant pump is there. Okay, so these are certain additional setups which are required in case of the TIG welding. That's why what happened, compared to the other shielding arc welding processes, the cost of this setup is quite high. Okay, so running cost of this equipment of the TIG is quite higher than if you compare with the MIG and all. Okay, so here inert gas is supplying the inert gas. See, it is coming through the small annular space and protecting the weld pool from the atmospheric contamination. At the same time, this coolant is flowing through these pipes which are wrapped around these tungsten electrode to keep the minimum temperature of tungsten electrode. Okay, now here in the TIG welding, if we talk about the power source, okay, so you can use both the alternating current or direct current as a power source in the TIG welding. And when you are using the direct current, so direct current, again you are having the two polarities, that is direct current electrode negative, that is straight polarity, and direct current electrode positive, that is a reverse polarity. Both the polarities we can able to use here. Only thing is that we know that in the direct current straight polarity we will get the maximum temperature at the workpiece, that is the workpiece is given with the positive terminal and the electrode is given with the negative terminal. So the advantage of that, what we are getting the maximum heat or maximum metal is going to melt at the workpiece. Okay, but if you talk about the direct current reverse polarity, that can be also used. But see, the current carrying capacity for the direct current straight polarity is around 10 times as that of the capacity of direct current reverse polarity. Okay, also we can use the alternating current here. So only thing is that the terminals are uniform, alternately changing. That is, see, in the TIG welding, if you are using the alternating current, the terminals in a single second they are changing for 50 times. Okay, so positive to negative, negative to positive, like that. You can say 50 hertz power supply, you can say like that. So this is for alternating current also you can use. Now if we talk about the main purpose or the application of this TIG welding, that is, we know that application is for it is basically suitable for highly reactive materials. But see, when the plate thickness is less than equal to 5 millimeter, this welding is quite very suitable. Okay, but whenever we are going for the thicker plates, more than 5 millimeter thickness plates that you are going to weld with this TIG process, so definitely there is a introduction of the filler material will come into the picture. You have to add some extra additional material via the filler rods. So if I show here the filler rod, when I use here, this is a filler rod. So filler rod is come into picture when you are going for the weld of thickness of plates more than 5 millimeter, or the thicker plates. If you are going to weld by, you require this filler rod, you have to supply some additional material into this weld. Okay, but the basic thing is that this filler rod, whenever you use the filler rod into the TIG welding process, definitely once you are using the filler rod, you will clean that filler rod before using into the process. But what happened, there are some air particles or small dust which are present onto the filler rod, which will carry through this filler rod and get enter into the weld. That is the thing, that is the limitation of that using a filler rod, that some impurity definitely is come and mix up with the weld material and make the weld contaminated. Okay, That's it. That is one limitation of the TIG welding. That is, thicker plates definitely require the filler rod, and when filler rod use karoge, some amount of impurity definitely come and mix into the weld pool. And the another limitation of the TIG welding is that, see, as the tungsten is having very high melting point, definitely it is not going to consume. But what happened at very high temperatures, even though tungsten is not going to melt, but at the higher temperatures, what happened, from the tip of this tip of the electrode, the tungsten atoms are going to diffuse. The tungsten atoms are going to be diffused and get mixed into this weld pool. And you know that tungsten is highly brittle. So definitely when the tungsten is going to get into this weld pool, definitely the brittleness of the weld is going to be increased. And this is not allowed actually, isn't it? So two limitations for the TIG is that once you are going for the thicker sides, you need to introduce the filler rod, and definitely contamination is going to happen. And the second thing is that the electrode, even though it is not melting, if we talk about the advantages, so up to 5 millimeter thick plates, highly reactive materials can easily weld, aluminum, magnesium, stainless steel. We are having both the power supplies, AC, DC we can use, right? And if you talk about the welding positions, very importantly, so whatever the welding positions, these are horizontal, flat, vertical, overhead. See, all the welding positions that we are using in the gas welding, we can use in the TIG welding operation. And also whatever the welding techniques that we are using into the gas welding, we can also use as it is into the TIG welding process. Okay. So students, this is about the TIG welding process. Now the next welding process we are going to see is that the MIG welding, that is metal inert gas welding techniques. Okay, thank you.